All right, here we've got the sine function on 0 to pi over 2. That's this little curve. So that's sine x, 0 to pi over 2. And I'm trying to find the volume of this using the disk method. And I did this example specifically to illustrate when you have to invert a function to get a radius of a disk. So let's look at a disk sliced out of this thing along the symmetry axis. Something like that. And so when you're getting the radius of the disk, you have to find the distance from, let's see if I can use a little more visible color here. You have to find the distance from the y-axis to this location on the curve. In other words, you have to find the x value corresponding to a given y value for the location of the disk. That means you're inverting the function. So if I have a y equals sine x, then that x value, the radius of the disk, is going to be the angle whose sine is y, or sine inverse of y. So there's that. And that's really the ugly complication of this problem. The thickness of the disk over here is just a little dy. So I set up my volume element dv. So I have dv is going to be equal to pi times the radius squared times the thickness. Now that we've got that volume element set up, we use integration to add up all the volume elements. We are summing all the volume elements. Pi inverse sine y squared dy as y goes from 0 to 1. And so right now we don't have the tools to do this. This is something you learn in Calculus 2. So what I asked is to use a computer algebra system to get it done. So we're going to use maxima for this. And I'm going to take the integral from 0 to 1 of pi inverse sine squared dy. In maxima, the symbol for the inverse sine is a sine, that stands for arcsine. So here it is, pi times the square of the arcsine of y as y goes from 0 to 1. And we end up with this nice answer, pi times pi squared minus 8, all divided by 4.